Green Thread HP by NOV Fiberglass Systems is a glass-reinforced epoxy piping system that has been solving complex corrosion issues in a variety of industries for over 50 years. It provides excellent internal and external chemical resistance in a wide array of challenging surfaces. Being non-metallic, Green Thread HP all but eliminates the corrosion issues associated with traditional metallic piping systems. The glass-reinforced epoxy laminate structure provides mechanical properties and pressure and temperature limits that far exceed what can be offered by typical non-reinforced thermoplastics. Green Thread HP16 is produced from an aromatic amine-cured epoxy resin system that provides enhanced high-temperature performance when compared to less advanced vinyl ester resins. Green Thread HP is available in 1-inch through 42-inch diameters. The standard design is rated for continuous operation at 93 degrees Celsius at 16 bar. NOV Fiberglass Systems is the world leader in adhesive bonded joint technology. All diameters of Green Thread HP16 utilize an adhesive bonded tapered bell by spigot joint for pipe-to-pipe and pipe-to-fitting connections. This joining system provides the fabricator with a repeatable, high-quality bonding system that can be rapidly assembled in a far faster and more user-friendly procedure than less advanced bonding methods, such as laminated butt and wrap joints. This video will provide an overview of the bonding procedure used for the fabrication of large-diameter adhesive bonded bell by spigot joints. The specific piping in the video is 30-inch, 16-bar rated Green Thread HP, destined for high-temperature, saturated brine service. Prior to starting work, ensure that the installation crew has access to adequate personal protective equipment, coveralls, Tyvek or equivalent protective suits, safety boots, hard hat, safety glasses, hearing protection, full-face respirator or face shield, safety glasses, and dust mask if preferred, gloves for general use, disposable nitrile gloves for working with adhesives, leather gloves for handling electric heating blankets. Required hand tools for fabrication include 6-inch angle grinder with a segmented diamond blade or masonry blade, adjustable speed die grinder with 40 to 60 grit bore polisher, 2-inch wide 40 to 60 grit sandpaper roll, 40 to 60 grit sandpaper sheets, levels and squares, a pipe wraparound, permanent markers and paint markers, clean rags and lint-free paper towels, wrenches and a set of metric and SAE Allen keys. Required specialty equipment includes pipe clamps, fitting clamps, and a flange puller compatible with the pipe diameter that is being fabricated, hydraulic come-alongs and related accessories, heating tools including electric heat guns, a propane torch with spreader tip, electric heating blankets, and an infrared thermometer, a compatible tapering tool. It is good practice to visually inspect all Green Thread pipe for damage upon receipt. For projects that require full traceability and bond mapping, it should be verified that pipe production numbers are legible on all pipe lengths upon receipt. During receiving, the pipe should be stored on wooden dunnage to prevent point loading and impact damage. Because of the light weight of Green Thread pipe, lifting equipment requirements are generally simplified when compared to metallic piping. Nylon slings and chokers should be used for lifting. Do not use chains or cables. Refer to the specific storage and handling instructions within the NOV Fiberglass Systems INS 1000 Installation Handbook for more information. Pipe should be stored with end protection left in place to preserve the bell and spigot bonding surfaces until required for fabrication. The end protection is removed by cutting off the banding and then removing the cardboard and plastic layers to expose the bell or spigot end. Maintaining pipe end protection during storage will minimize the sanding activities required during bonding. Well-protected pipe ends will only require light sanding to expose clean glass fibers prior to adhesive application. Weathered pipe ends require substantially more work to prepare them for bonding. A permanent marker or paint pen is used with a pipe fitter's wraparound to scribe a line for cutting. The pipe is cut with an angle grinder. A segmented diamond blade is the ideal choice, but masonry blades are also acceptable. After cutting, the pipe production number is transferred to the cut section to maintain traceability. The cut pipe with spigot end is positioned in line with the bell end in preparation for bonding. Large diameter bell and spigot joints are assembled with hydraulic come-alongs. The come-alongs provide the force required to drive the bonding surfaces together, producing a thin layer of adhesive called the bond line. Steel pipe clamps are installed on the bell end of the pipe, along with the hydraulic rams that will be used to pull the joint together. The hydraulic hoses and hand pump are connected to the hydraulic rams. Steel pipe clamps with rubber liners are installed on the spigot end of the pipe along with chain lugs. Reference marks are added to the pipe wall next to the pipe clamps to monitor for slipping of the clamps during joint makeup after hydraulic force is applied. The clamp bolts can be tightened later if necessary. For the first bond in this fabrication project, the installers perform a dry fit of the factory bell and spigot ends to confirm that joint tolerances are to specification and that the final bonded joint will be in line with published joint makeup dimensions. The bell end is prepared for bonding by sanding with a die grinder and 40 to 60 grit bore polisher. The bell is then hand sanded with 40 to 60 grit sandpaper. The spigot end is hand sanded using a 2-inch wide strip of 40 to 60 grit sandpaper using a shoe shine technique. Excessive dust is wiped off of the bonding surfaces using a lint-free cloth or rag. The freshly sanded bell and spigot must be bonded within 2 hours. If bonding does not occur within 2 hours of sanding, resand both the bell and spigot. Keep the bonding surfaces clean and dry. Chains are connected to the hydraulic rams and chain lugs in preparation for joint makeup. Reference marks are added to the spigot end of the pipe to check final insertion depth and joint lockup. A propane torch and spreader tip is used to gradually warm the bonding surfaces of the bell and spigot joint. The bonding process is temperature sensitive. If temperatures are too cold, the adhesive will be difficult to mix and apply. If temperatures are too warm, the working life of the epoxy adhesive will be reduced. Specific guidelines for warming procedures are based on shop and field conditions. The bonding surface temperatures are verified with an infrared thermometer. Cold weather installations typically utilize heat and hoarding to streamline bonding operations. GreenThread HP is installed year-round in cold climates. Adhesive kits come packaged in boxes of 10. Each kit includes a container of resin, a container of hardener, instructions, and accessories. The fabricator should read the instructions and relevant safety data sheets prior to starting work. Resin and hardener containers are labeled with production numbers for projects that require full traceability and bond mapping. Verify that the adhesive you are working with is not expired. To streamline adhesive application once bonding commences, the required adhesive kits for the joint at hand are opened and staged for mixing. Before mixing, resin temperatures are verified with an infrared thermometer. The hardener is added to the resin. Always combine the full quantity of both resin and hardener together. Never attempt to split a kit. Thoroughly mix the resin and hardener together. Scrape the sides and bottom of the resin container to ensure that the contents are completely mixed together. After mixing, the adhesive should have a smooth consistency and uniform color. The adhesive is ready for application. Applying pressure to the long edge of a hardwood stir stick, a thin layer of adhesive is scraped into the bell end to wet out the glass fibers on the bonding surface. Excess adhesive on the bonding surfaces will squeeze out of the joint when hydraulic forces are applied. It is important to use enough adhesive so that some squeeze out is observed evenly around the circumference of the joint after hydraulic force is applied. This is an important visual cue indicating that there are no voids or dry spots within the bond and that the joint has been locked up. The same procedure is performed on the spigot end. Excess on the bell end tends to squeeze out into the pipe bore. while excess on the spigot end tends to squeeze out of the joint onto the outside of the spigot end, where the squeeze-out can be observed and subsequently cleaned up. A second, thin application of adhesive is made to the spigot end to ensure adhesive squeeze-out. The face of the spigot end is covered with a light coating of adhesive to seal and protect exposed fibers from the process fluid. The spigot end is aligned with the bell end and stabbed into place. The installers check the gap at the bell to ensure it is uniform around the pipe's circumference, a visual indication that the joint is adequately aligned. The chains are connected to the hydraulic rams. Hydraulic pressure is applied to retract the rams and draw the spigot into the bell. Dead blow hammers are used to aid in joint lockup. Vibrating the joint assists with driving the spigot deeper into the bell. The pump operator monitors and maintains hydraulic pressure while the joint is hammered. Hydraulic pressure drop is monitored after successive hits with the dead blow hammers. When pressure drop is 200 psi or less after 3 consecutive hits with the dead blow hammers, the joint is locked up. The installers measure from the face of the bell to the reference lines added to the spigot end to check final insertion depth and verify that it is within specification. An electric heating blanket can be used to accelerate joint cure time. This process can be initiated as soon as joint lockup is achieved. For high-temperature applications, it is recommended that all joints be force-cured to maximize mechanical strength and chemical resistance. Refer to the specified adhesive system's instructions for recommended cure times. Pipe nipples can be cut and tapered in the shop or field using a portable lathe tool. The tool is inserted into a square-cut plain pipe end. A series of threaded rods are tightened to hold the tool in place. The drive motor is installed on the tool, as is the striker plate. New carbide blades are installed in the blade holders. The tapering tool indexes forward automatically, machining the pipe end into a tapered pipe spigot. The cutting arms are retracted using a drill and the tool is removed from the pipe. The bonding process for flanges is the same as for pipe-to-pipe joints. A second, thin application of adhesive is made. A thin layer of adhesive is then scraped into the bell of the flange. The flange is pushed onto the spigot end. A steel flange puller is positioned across the face of the flange and connected to the hydraulic rams with chains. Hydraulic pressure is applied to drive the spigot into the flange bell. To ensure that joint lockup is achieved, wooden blocks are positioned between the flange face and the puller to make space for the spigot to pull through the flange face if required. Dead blow hammers are used to aid in joint lockup. Hydraulic pressure is monitored and maintained. Electric heat guns and rags are used to clean up excess adhesive on the flange face before installing an electric heating blanket. If the spigot is protruding slightly past the flange face, it will be sanded flush and sealed with epoxy adhesive after the joint is force cured. For bonding fittings, the same adhesive application technique is used. The bell of the elbow is aligned with the pipe spigot and stabbed into place. Once again, hydraulic come-alongs are used to lock up the bell and spigot joint. Dead blow hammers are used to aid with lockup while hydraulic pressure is monitored and maintained. The opposite side of the elbow is assembled using the same process. The adhesive bead is cleaned up after lockup is achieved. Where accessible and when confined space entry is permitted, squeeze out from joint lockup inside the bell can be cleaned up. If you have any questions about this video or about any of the premium fiberglass piping products that we offer, then please contact us today.